Assalamualaikum. My name is Muhammad Mizuddin bin Aladin, matrix number DN220126. So I will talk about the introduction. So first is our problem statement. First one is component integration efficiency, too many parts or components, and cost of materials. So for the objectives, to understand the difference and similarity between design for manufacturing and design for assembly. Second one is to optimize and enhance the current bicycle design. And last one is to achieve cost reduction through component minimization. So next, I will talk about the literature review. The design and manufacturing of bicycles have evolved significantly over the decades, driven by advancements in materials, production processes, and design methodologies. As one of the most widely used modes of transportation and recreation globally, bicycles serve as a cornerstone of mechanical engineering innovation. This literature review explores the integration of the FMA principles in bicycle development, highlighting key insights, challenges, and opportunities for optimization. So moving to the first part, which is design for manufacturing, optimizing product designs to streamline and improve the manufacturing process is the focus of design for manufacturing. DFM's primary objectives are to choose materials, simplify designs, optimize processes, and guarantee attainable tolerance and standards. Manufacturers may drastically cut lead times and production costs by carefully choosing affordable, easily processed components and streamlining the product's overall design. Process optimization also guarantees the effectiveness and dependability of the manufacturing methods used, promoting a smooth transition from design to production. The second part, which is design for assembly. DFA is an analytical approach that gives the designer a framework for thinking or direction so that the product may be created in a way that improves the assembly process. The FA is, in other words, a method of product design with the means for a production that seeks effort and cost reduction associated with the assembly process. So the third part, which is DFM plus DFA, design for manufacturing plus design for analysis. Design for manufacturing and design for assembly concepts have become integral to engineering success in the dynamic field of product development. DFM and DFA is the aggregate term for these approaches, which are essential to producing high quality, reasonably priced, and user focused products. So, the picture in this slide is the steps for the FMA methodology. So, the last part, which is our product, which is bicycle. Bicycles have long been recognized as a sustainable and efficient mode of transportation, offering numerous health, environmental, and economic benefits. Over the years, advancements in bicycle design have focused on improving performance, comfort, and safety, while also considering manufacturing and assembly efficiencies. This literature review explores the evolution of bicycle design, with a particular emphasis on design for manufacturing and assembly principles, which aim to optimize the design process to reduce costs and enhance product quality.
Now I would like to present about methodology, which is provide a detailed overview of the process, tools, and technique employed to achieve the objective of the project. In this chapter, we outline the step-by-step approach followed in the design, development, and manufacturing of the assembly system. So, there are several steps in manual DMA. First one is define product requirements. It, it sets the foundation for the entire design process and comprehensive understanding of what the product needs to achieve will guide the design decision and ensure that the final product meets expectation. Then the second one is simplify the design using SolidWorks. which is that can reduce production costs, consolidated part where possible, or eliminates unnecessary parts, change components that have more expensive materials to cheaper but better quality ones, and speeds up the manufacturing and assembly process. This step is focusing on minimizing complexity and optimizing efficiency. And the third one is material selection. It is crucial to achieve a balance between cost, performance, and manufacturability. The material should not only meet the functional requirements but also align with the manufacturing process. And then the design for manufacturing analysis, which is design decision should always consider the manufacturing process and used to produce the parts. A good design is one that can be easily translated into an efficient manufacturing process, minimizing waste and cost. And then DFA, which is designed for assembly, designed for parts that are easy to fit together with minimal steps. Besides that, reducing the number of fasteners, lower labor time, and reduce the chance of assembly errors. Other than that, ensure that parts are easy to pick up and insert during assembly. The goal of DFA is to minimize assembly time, complexity, and cost. After that is about DFA table, which is uh, the key components such as part ID, C1 to track each component, number of operations, C2 to count the assembly steps, manual handling code, C3 to classify handling difficulty, and manual handling time, which is C4 to estimate handling duration. Additionally, manual insertion code, which is C5, and manual insertion times, which is C6, evaluate the complexity and time needed for part insertion. Operation time C7 is determined using the formula, which is C2 times in bracket C4 plus C6, while operation cost, which is C8, is estimated as 0.4 times C4. The estimation for theoretical minimum parts, which is C9, provides insight into reducing part count to streamline assembly. This worksheet supports efficiency measurement by quantifying assembly time and cost, help identify complex or redundant parts for redesign, promotes standardization of components to align with pre-cut manufacturing strategies, and incorporates a design efficiency calculation, which is 3 times NM divided by TM to balance manufacturing cost and product customization. It can see in example of DFA table in the slide. And the last one is about report and documentation, which is essential for effectively communicating the findings and methodology of the project. Can involve careful planning, systematic data collection, and organized writing to ensure clarity and coherence. Visual aids and appendix enhance understanding, while to review and revision improve accuracy. Properly documentation provides a comprehensive record facilitating transparency and enable future reference or replication. So that's all the steps in manual DFMA. Thank you.
Hello, I'm Kunaran Mohan. My matrix number is DN210032. Now I would like to explain about my part in our dfma project. My part is results and analysis, and we have done a project based on a bicycle which we showed in the picture below. Okay, now list of the components for our project is stem cap, handlebar tape, brake, shift gear level, headset, head tube frame, top tube frame, down tube frame, seat stay, seat post clamp, saddle, fork, chain stay, hub, caliper brake, brake pads, brake cable, tire, valve, rim, pedal, crank, bottom bracket, chain wheel or chain ring, chain and sprockets. Okay, next we are about to show the improvement we have done in our project. The sections are headset, handlebar, and fork. The components are bowl, washer, cover, beams, bearings, bolts, screws. Enhancement or reduction of our project is to redesign the shape of the stem and use magnetic of the joint part to neglect the small components and fasteners. These are the symmetric axes that we used for handlebar, headset, and fork. The next part of improvement we have done to our project is crankset, which includes the components of crank arms, chain rings, spider, bottom bracket spindle, bottom bracket bearings. The enhancement of this is redesign the crankset with no screws or handmade joints. New design include a socket which can just be attached without screws. This reduces the manufacturing time and workload. This also is the symmetric axis we used for our crankset. Okay, now this is the explorer view of our redesigned model. These are the original design efficiency of front bicycle section. This is the original design's efficiency of middle bicycle section. Next, we would like to present about the DFA analysis of improved design. This is improved design efficiency of front bicycle section, and this is the improved design efficiency of middle bicycle section.
I am Melvin Bryan, and as for the conclusion of this project, we goes by our motto, which is smarter, simpler, and better. We have applied dfma into this project to enhance the bicycle, which we were able to focus on reducing the parts using different materials which are more cost effective, as well as increasing the efficiency of the manufacturing. So what did we achieve from this project was we were able to use fewer components, which adds in easier and faster assembly. We were also able to use advanced simulation, which ensured top-notch performance for this project. And last but not least, we were able to lower the production cost of the bicycle by making it more budget friendly without sacrificing the quality of the bicycle. And that is it for us. Thank you.